In our brief history of computers, we looked at ENIAC, the Electronic Numerical Integrator and Computer, first installed at Aberdeen Proving Ground in Maryland in 1947. And I mentioned that it was used both for developing the hydrogen bomb and also calculating ballistic tables for artillery. Ballistic tables for artillery show different trajectories based on the amount of force behind a projectile and the angle at which it is fired. And that's somewhat significant for how we actually draw on the computer, because in physics a combination of force and direction is what they call a vector. So I have this little cannon that I usually draw on a whiteboard in a face-to-face class, and it comes out a little different every time. This time I decided to draw it as a vector drawing to demonstrate vectors. So here's my little cannon, and you can see inside my little cannon there's a cannonball, here's a propellant, and here's a fuse to ignite the propellant. And if I hit a target here, there we go, there's my target, and the cannon is perfectly aligned to the center of the target, but that's not where the cannonball goes. If it was fired in outer space, it would be subject to only Newton's first law of motion, which is an object in motion tends to remain in a state of uniform motion unless acted upon by another force. On Earth, we have other forces. We have air resistance and gravity, and that causes my cannonball to drop rather quickly. Well, kind of depending on how much force is behind it, how quickly it will drop. But somebody, I think it may have been Galileo, established that if an object is dropped or thrown, it reaches the ground at the same time. So if this cannonball came out the end here and just fell out the end and dropped, and another cannon next to it has one fired while this one drops, they would actually both reach the ground at the same time because they're in the same gravitational field. So even though this one can go a lot farther, it's still going to end up on the ground. So this path, this is a trajectory, is determined by vector forces. So vector forces, I just happen to have some vector forces here somewhere. Yeah, there they are. So whatever amount of powder I have in my cannon pushes on the cannonball, and that's one force in that direction. But coming out of the cannon, it is immediately affected by gravity and also air resistance, and that causes it to slow down, and the more it slows down, the faster it falls. To compensate for that, you have to have a calculation that tells you at what angle your cannon needs to be and how much powder you need to have in to give it the requisite force for a certain distance in order to get that cannonball to hit its target. So there's the vector forces at play here. I actually added one. We have the force behind the cannonball pushing it in a straight line, but gravity pulls it down, air resistance slows it down, and you may also have a cross component of wind which will cause it to drift left or right on the target. Now, what does that have to do with drawing on a computer? Well, I drew all those things with something called a vector drawing tool. So for instance, when I wanted to show a straight line from my cannon, I'm going to use the same colors I used before. I used red for that stroke. Okay, here's my red, and I will use my pen tool and create an anchor point, and I'm going to hold the shift key to constrain to a straight line, so I'll constrain to horizontal or down 45 or up 45 or up 90 or back this way at let's see, that'd be 135 degrees, 180 degrees, 270 or 360 degrees. So, or north, south, east, or west, and the 45-degree components in between. I'll click over here. I've just created 2 anchor points. I'm going to hit my escape key to end that drawing. I'll make it a little thicker for you. Okay, so what you see here, I'm gonna cyan colored layer, so it shows the path as a cyan line. It shows the anchor points as little cyan squares if they're selected. If they're not selected, then it shows them as a white square with a cyan border. So you see a red line because I've applied something called a stroke to it. The line itself, I'm going to go into the what we call drawing mode, Command Y, that's the toggle, and you can see a black line representing where the path is. The path is a mathematical construct. It's the result of formulas, equations. So a mathematical formula says that if I have a point at xy and a point at xy and a straight line in between, that's where it is, but this is a representation of it because it only exists mathematically in the computer. We go back into preview mode, and it previews that I have applied a red stroke to it, and the stroke is centered on the path, and this is a, what did I say that was? I think that's a 2-point stroke, 4-point stroke. So it's 2 points above and below, or inside and outside my path. I don't have a fill on that because you can't actually fill something that's a straight line. If I had a square of the same description and put a white fill in it, there's a white fill and a red stroke on my square path or shape, a shape consisting of 4 subpaths or 4 segments of a path, and it meets where it started like this. So it's a closed path. You'll notice when I did that, I could also have an open path that would be filled. So there's my straight line path. If I want to draw a curve, such as I showed in my trajectory diagram or drawing, I would click and drag in a direction and for a certain length, and this is the equivalent to the cannon giving, or the charge in the cannon giving the cannonball a push at a certain direction and with a certain force. So if I say it's going this way with a lot of force and it lands over here with less force because it's slowing down, depending how fast it slows down, I'll escape to end that drawing. And that's how you draw a curve with what we call vector drawing, or this is a vector drawing or a vector curve or a Bezier curve, named for Pierre Bezier, who was one of the first to actually formulate this back in the 1960s. He was a designer for Renault car company in France, and this is how he calculated the curves to the body panels of Renault designed at that time. So if I want to change that, I can use my direct select tool. That's the white arrow in your tool palette. Here's my tool palette: white arrow, direct select, black arrow, object or main selection tool. This is my pen tool. This is how I drew this. If I want to see what other pen tools I have, I can pull this off by hit that little corner. I got to fly out, touch this bar over here, and now I can have that pen tool there. I'll move my main tool palette back out of view. So I can add points with the add anchor point tool. I missed. There we go. Here, right there, add an anchor point. I can subtract an anchor point with the subtract anchor point tool, and I can change anchor points with the anchor point tool to be either straight. Just click on this, and this now has no vector force applied to it, or I could click and drag out a handle so that I turn that back into a curve. If I have a more complex curve, let's say I got this, that, and this, and I then use my anchor point tool, I can change this one right here. I'll leave that that way, but I can grab this and make that a straight line by pulling it in, or have it create this little angle here by grabbing one of the direction control handles. So the this gunpowder, so to speak, of my cannon as I'm doing this is the direction control handle, which controls the direction and force applied to that curve. Our first exercise will be to get you familiar with the pen tool, and we will primarily just be using the pen tool, and I will show you how to add some keys on the keyboard to what you do with the pen tool to access different things and be able to do different things with it just with that one pen tool.